Correct. Guys. Sorry? Yeah, man, of course. Okay, guys. Yo. All right, let's get back to integration. Exciting. First of all, a couple of observations right off the bat. So let's just call them literally observations or clarifications, okay? Observations, clarifications. First one is, you know, I wrote all the time, integral f of x dx. Yeah, this thing is just a notation showing you what is the variable, okay? For now, you don't play with it, you don't raise it to the power, you don't multiply it by anything, it's just there as a notation, okay? First observation. Second observation is in the definite integral. It's quite normal, or the way you compute it, to have like the lowest number down and the bigger number up. So what do I mean by this? When I write something like this, it's usually better, in order, because it helps you with computation and it makes it less confusing afterwards, to have a smaller than b. Okay, just a general way of writing. If you get integrals, in which case it's flipped, like you get integral of 1 to 0 f of x dx, we just use the property where you had this is equal to minus from 0 to 1. Sorry about that. Of f of x dx. Okay. This is just a personal preference. I like to have my integrals in a normal increasing way because I believe it helps with computation and it helps me not do stupid stuff. Okay, cool. These are some of the observations I want to start with. Observations, clarifications. If there are any other questions, just ask me now. And literally anything about integrals. And then if there are no questions, we're just going to move to some more by parts. Since I don't know if you managed to look at the hand-in, I did, but there's got to be some integration by parts there, no surprise. So let's work a little bit more on them, on those, okay? Cool. Also, I think Zoom room hopefully gives them. So any questions, or do we move to some more computation of this stuff using the by parts thing? Okay, so I'll write out the by parts and let's try a different approach. So what is the by parts theorem is, or method is, if you have integral f prime of x gx d of x plus integral of f of x g prime of x dx is equal to f of x multiplied by gx. One question that I got here, is there any intuition behind it? No, the only intuition behind it is the fact that it comes from the derivation of a product, okay? That's the only intuition that you got to keep in mind. What did that look like? If you had derivative f of x multiplied by g of x, derivative of x, okay? This was equal to f prime x g of x plus g prime plus, let's keep the order, fx multiplied by g prime of x. Okay, this is the only intuition I can give you for this. Otherwise, just take it as it is, which is just a way to help you compute integrals. Okay, cool. So now let's actually do some computation. Let's do integral of x squared log of 4x dx. And you might say, hey, we kind of did another log or something. The idea is that this method is extremely, extremely used in exponentials. When you see an exponential multiplications. So let's say exponentials, powers, and logs. Okay. This, when you see something like this and you don't know how to solve it, think of by parts. Okay, these methods are for some reason, these ones, just computational reason, no other reason behind it. They just work really nice with by parts. Okay, so when you see something like this, you don't know how to solve it, think of by parts. Cool. Now let's come back to our thing. Again, we look at this, we do not know how to solve it. So we see the log, we see a power, so we think of by parts. Now we want to create by parts. In order to, why is this so soon now? Okay, this is better. Okay. In order to use by parts, we have to have a derivative. There's no derivative I have here, absolutely no derivative. So I have to create my own derivative. And create my own derivative is just a fancy term for basically replacing a term with the thing that, with the antiderivative or the primitive or the integral, definite integral of it. So in this case, you know, x to the power of 3 over 3, everything derivative is x squared. Okay? Or whatever you want to call it, the indefinite integral of x squared dx is equal to x3 over 3. Okay? However you want to phrase it, however it works, so you keep in mind what you have to do. Okay? But this is the first step. You create your own derivative. Now, let's look at my equation. What do? I just replace my x squared inside there with this derivative thingy. Okay, so I get x to the third over 3 derivative log of 4x dx. Okay, now keep in mind, I want to apply the formula, this formula here. This is what I want to apply. So let's just write it with f and g, okay? So let's say in this case, my f of x is x to the third over 3. My g of x is log of 4x. Okay? So let's just write the formula using these notations. Okay? What is my formula? My formula is integral of what is can I zoom more so you actually see the thing up top? I can't. But you have it in your notes. This is the equation I'm using, okay? Which is the by parts thing. So I'm just going to replace with my values inside of it. So f prime, f of x is just x to the third. So it's x to the third over 3, everything prime, multiplied by g of x, which is log of 4x dx. Again, you can follow what I'm doing on the notes or in the formula that you have in your notes. It's kind of hard for me to put them all here. Okay, plus now integral of f of x. So that's x to the third over 3 multiplied by g of x derivative. So that's log of 4x, everything derivative, e of x. Okay, and this is equal to f of x over 3 multiplied by log of 4x, which is g of x. Cool. Any questions? Good. Hopefully. Okay. Now, why am I doing all of this? Because this is what I want to compute. Okay. What I want. It's right here. Okay. It magically popped up here. This is what I want to find out. This, I don't. Oh, sorry about that. Okay. So why do I write x to the third over 3 derivative? Well, I made the claim that x over 3 derivative is x squared, and when you're writing, you can definitely just write x squared here instead of my derivative. Definitely. The only reason I'm writing it as a derivative right now, just so just so you know exactly how to apply the formula and where it comes from. Okay, I just, in my opinion, I just think it would have been a little bit maybe harder if I, instead of this, I just wrote x squared. Okay.
When you wrote f of x, you wrote the integrated one, but then g of x is the one from the.
Yes, exactly. And that's the whole idea. In order to start by parts, you have to have one of the functions being the integrated of what you see. Otherwise, you cannot start by parts.
Okay, so before you start by parts, you integrate half of it.
You integrate
and
a
then
part
you
of
go
it.
by part.
You integrate a part of it. Exactly. You have to integrate a part of it first. That's like what integrate a part of, that's the process of what I call create your own derivative, right? Because when you look at my thing here, there's no derivative of it. I have two parts and no derivative of it. So I have no idea how to apply the by parts thing. That's why I integrate one of them just so I manage to have this derivative here and start the by parts procedure. Okay? Yeah.
I think the question is saying but just when you added like the rest of the formula, I think the question was directed
Here. Okay, yes. So I think this is where the question from in front came, which is why do you integrate first? I cannot apply the by parts formula to my x squared and log of 4x. I cannot apply the by parts to it because let's look at my formula. My formula, or at least, in both the integrals, I have a derivative. Whatever integral I choose, there is a derivative there. And these two, none of them are derivatives. Okay, so that's why I integrate one of them first, so I can apply the by parts. Okay. Okay. Okay, let me write again. So what I had was x squared log of 4x dx. Now let's write the by parts here. My by parts is something like this: f prime of x gx dx plus integral f of x g prime of x dx is equal to fx gx. Cool. So I have this. Now, imagine you're in this situation. You're given to compute this, and I'm telling you use this. How can I use it? Well, clearly, I want to make this thing, the one I need to compute, be equal to one of these two things. Okay? And obviously cannot be equal to the one on the right side. There's no integral on the right side. There's no integral on f of x gx. So I need to make one of these two be equal to that thing. Okay? Now the problem is that both these formulas have a derivative, either f prime or g prime. Mine has no primes. So in order to make it look like that, I need a prime. I need a derivative in. I need a primitive in. So that's why I just take one of them as my primitive. Now, in some problems, it might not be obvious which one you choose, right? Because let's just say, okay, I'm not going to call it f or g, but let's say my integral here has first part x squared, second part log of 4x. Okay? Again, no derivatives. I need to have a derivative in order to apply the by parts. So I'm going to choose to compute the derivative, the antiderivative or the primitive of this thing, okay? Of the first one, of x squared. I'm going to choose. You can apply it on the other side. You can apply it for this one as well. But I'm going to choose for x squared. Why? And you're going to ask me, okay, how do I know which one is the correct one? The answer is you don't. It's just the practice. And what I do is I just take the easiest one out. In my case, I don't know what the primitive of log of 4x is, but I know the primitive of x squared is pretty simple. Okay. So There's no rule that you always take the first one or the second one or something. You always take whatever works better in terms of computation. And in this case, x squared looks pretty good. Okay. So you choose one of these, whichever you want, and you compute the integral of that thing, dx, the short integral of it. In my case, it's just x to the third over 3. Okay, plus a constant, but in this case, you know, we don't care about the constant. Okay, now I have a derivative. Like I have that x squared is equal to x to the third over 3. I have created my derivative. And if you look inside the formula, the function or f of x is taking derivative of. I can use this other one as well, but it's still derivative. Like derivative, like the idea is that my f of x or g of x can never be x squared if I choose this, if I choose this derivative, if I choose x to the 3 over 3 derivative, okay? It can't be, because then it means that if, okay, let's assume if my f of x is x squared, it means I have to take a derivative of it as well, right? I have to take a derivative of it again, and I need my g prime in that case. I need g prime to be log of 4x. So I need to compute that as well. It becomes really complicated. Okay, becomes really complicated. The idea is that when you take a prime, when you compute this prime thing, what's inside taking derivative becomes one of your functions, becomes an f of x. I don't know, I'm trying to go intuitively, but I think I'm more overcomplicating. It's just purely like mechanical. There's no behind it. You just split your function into the two parts, choose one, whichever is easiest, compute the integral of it, or the antiderivative, or whatever you want to call it, and just make that your f of x. Okay? So once I have computed this, I just make this my f of x. And the other thing that I have not computed the antiderivative becomes my g of x. So again, I got my two parts, x squared, and let's just consider this my discussion that has nothing to do with the main logic. So I have my two things, which is x squared, and then my second part, which is log of 4x. Again, no particular reason outside of convenience and the fact that I just think it's simpler. I choose to compute the antiderivative of x squared, and I got it. It's this thing. At this point, what you do automatically, like I think once you have a little practice, right, a little bit more, it becomes automatic. It becomes automatically to say, okay, my f of x is x to the third, and my g of x is the thing I did not compute the antiderivative of. Okay? It should just become automatic. And once you have this, it's basically just plugging in your function and replacing. And then computing, and then the problem is magically done through this math thingy that doesn't really make sense why outside of like the derivation rule, but it works. Okay. So again, I have these things, so I'm just going to plug them in. Let's see if I can make it have everything here. Kind of, not really. Okay, so I have x to the third over 3. And again, if you're not really comfortable with like writing it straight out, I genuinely recommend writing your formula up top when you're solving, when you have to do by parts, and just plugging them in without taking the derivatives, just like this. Like my f of x is this, multiplied by g of x, replacing d of x plus integral my f of x multiplied by derivative of g of x dx is just equal to both the functions multiplied with nothing else. Okay. Now once you have this, you can actually start solving it. Okay. Once I've computed this, I can actually start solving. What is the, I mean, look in your notebooks because I took it out, but what is the derivative of x to the power of x third over 3? Well, it's just integral of x squared log of 4x dx, which is what I'm meant to compute, what I want to compute. Okay. This is what the problem asked me to do. And unsurprisingly, I created an x3 to the third, so I get this. Okay. Now, plus the second term is just x to the third over 3 multiplied by what is the derivative of log? It's just 1 over 4x multiplied by. Okay. Just derivation of the log. Okay. Flip it and then multiply by the derivative of what's inside. Dx. And now this is just equal to, again, copy, nothing to do on the other side. Log of 4x. Okay. And why did I do this? Well, this is what I want to compute. This is done. Okay. There's no integral there. So I have nothing to compute there. On the other hand, now I just need to compute this. And I pray to God that this is easier to compute than my initial integral. And let's see, is it easier or is it not? Well, 4 goes away. And x here goes away here. I just have an x second left. Okay. Or if you don't like me simplifying from the start, I can just write it out. I just multiply everything, I'll get 4x to the third over 3 multiplied by 4x dx. And 4 goes away, and x goes away with the x third, so I got x second here. So all that I have to do is compute x to the power of 2 over 4 dx. And this is something that you know how to do. This is equal to. It's over 3. Yes, good point. It is over 3. This, okay, so apparently this step, I don't know how to compute, but this step now, you guys know how to compute. Again, I just do it a simple way. I take the 1, 3 outside, because as you probably notice, I'm bad with numbers, so I don't want to make another mistake. And this is just equal to third, x to the third over 3, okay, plus a constant. Okay, so now, this is what I want to compute. This is done, and I've gotten this for the thing in the middle. So what is my answer? My answer is x squared, integral of x squared log of 4x dx is, I'm just going to replace plus, replacing this thing, x to the third over 9 plus constant is equal to x to the third over 3 log of 4x. Okay, so everything that I had to compute is just equal to right side minus this thing. So minus x to the 3 over 9 and minus a constant, doesn't matter, constant can be negative or positive as well. So this is my answer. And if you don't believe me, just compute the derivative on the right side and you should get the left side. Okay, that's when you're doing integrals, if you're unsure or your result looks kind of yikes, just do a derivation of the right side. And if you get the left side, you did it correctly. But this is how you do by parts on indefinite integrals. Now, any questions on this? I'll give it like 1 or 2 minutes worth of questions, and then we're gonna do by parts on a definite integral, but don't worry, it's literally the exact same thing. Okay, so don't stress it. Yeah.
Shouldn't our f of x contain a constant? So we have g of x times x3/3 and g of x times c.
Where did you ask? Or was this here?
I mean, in the general formula, I guess. So we assume that, yeah, so there's a plus c there.
Yeah, there's a plus c here, but
In the integration by parts rule at the top,
yeah,
in f of a or on the right.
yeah, you're talking about this c right here.
No, in the when you multiply f of x by g of x.
F of x by g of x here.
Yeah,
Yes.
you're gonna have a term of g of x.
No,
plus c. You're not.
No. The idea is that you take the simplest version out. Basically, the idea is, okay, I mean, we can talk afterwards, but if you take the idea is that if I take a constant on f of x, like if I put f of x plus a constant and the other thing plus a constant, then everything's gonna cancel out with the right side. With the left side of the right side is gonna cancel out. That's a short discussion, but I think that's, we can talk afterwards. His question more or less, it was, hey, I said compute the antiderivative of this or the integral, right? The definite integral of a term. And he said, hey, you have a c here. Don't you carry that through? And the answer is no. Do not carry the c in this case. Okay, look at me. I don't carry the c. I just have an x to the power of 3/3. Do not carry the c. Okay, that was the point. But just, I mean, if you want, you can just take a c on f of x and g of x, and you're gonna see they cancel out. Cool. Any other questions on this? On the by parts? Thank you. Okay, then, yeah.
Why is it minus c and not plus c?
Great question. Doesn't really, I mean, I wrote it here, I had a plus c, so I moved it to c on the other side.
All right.
It doesn't matter. You can write plus c, doesn't matter. It's any constant you want. So if it's 2, I can make it -2 and make it all work. Doesn't matter. This c thing that you write, it's just because it's an indefinite integral and it's basically talking about all the possibilities, right? Constant goes away on derivation, so it doesn't matter. You can have plus minus c. However you want. What do you mean by free? Do you mean here? Yeah, this is my f of x. This is f of x. This is g of x.
Oh, I think she means the 9.
The 9 here. Yeah, it was from here. It was 1/3 here multiplied by the integral of x squared. So it's 1/3 multiplied by what the integral of x squared is, which is x to the 3rd over 3. So I multiplied them and I got x to the 3rd over 9. Okay. Cool. Okay. Let's do the by parts on definite integrals. If you think it actually becomes way different, no, it's exactly the same formula. So I'm going to write it again. Let's say f of x prime gx dx between a and b plus a and b f of x g prime of x dx. The only noticeable difference outside of the fact that you're going to have like you have a and from the definite part of the integral, which is like from a and b carried across, is that on the right side where we have f of x g of x, it is between a and b. Okay. That is the only difference. Everything else works the same. And if you're scared about, okay, we've gone from this notation, f of x or a function between a and b just basically means this, just basically means f of b g of b minus f of a g of a. Okay. So it's just like any definite integral. Nothing changed. Nothing changed. But again, the thought process and everything you do and how to solve like a definite integral using by parts is the same as doing an indefinite just that this time you actually are gonna have numbers instead of a formula in X. Okay, so let's just take an example if there are no questions here. Let's just do, I don't know, doesn't matter, X to the third. No, that's X e to the 6x. E of X. Let's do between 0 and 1. Okay. This is supposed to be a 6, by the way. All right, now, same step as before. What do? Split it into 2 parts. First part, X, second, e to the 6x. Okay, now, yeah.
Sorry, I want to say X and then what's the exponent?
There's no exponent here.
Oh.
It's I cancel. I was planning on giving X to 2020, just like a Neil's problem, but I said I'll leave it as an X for now. Okay, so just X there. There's no exponent there. Okay, so I have my first part X and my second part e to the 6x. And again, I have to compute the antiderivative or the integral or whatever of one of them, so I can start the by parts procedure. Now, remember, exponents are a great choice for this because they never go away. Okay, how many times you take derivative of it, they don't change. So exponents are a great choice for by parts, for computing the primitive. Okay, that's why I'm going to choose this one. Again, there's no logic behind it. It's just a computational thing. You choose e of x or e to the power of x because your computation is going to get simpler rather than complicated. If you want, as an exercise, you can do with x. Do it for x. Apply by parts for x, and you'll see it actually gets slightly complicated. Okay? Or if we have time, which I don't, because we only have like an hour. You're gonna see that you're gonna get an x squared here, so it's gonna get even uglier. Okay, if you choose the first part. How do I know this beforehand? If I've never done an integral, you don't. You just take my advice, which is take e of x. Okay. So compute the antiderivative of e of x. Whenever you say exponential, great choice for starting the point by parts. So I'm going to choose this thing. I'm computing the integral 6x dx, which is going to be equal to e 6x over 6 plus a constant. Again, use the formula, use whatever you want. I personally don't really care whatever you use, but this is it, okay? And remember, I'm only gonna use this thing in the by parts, not a constant here. When you're asked to compute an integral, you give the answer with a constant, though. But when you're asked to apply by parts, you don't care about the constant. Okay. So now, let's keep the order. My f of x is just x, and my g of x is just this thing. Cool. Now, question. Can you do this? F of x is equal to e 6x over 6, and g of x is equal to x. Answer, yes. Doesn't matter. Do it however you're comfortable with. Okay? The answer is going to be exactly the same. Why? Well, you have to include both of them anyway, and multiplication is, you can switch places when multiplying two stuff, okay? So again, don't stress about, I gotta keep it, if I choose the second one, it has to be g of x. No, you apply it however you want, okay? However you're more comfortable, however it's easier. So this is correct, both of them are correct. Any preferences on whichever I'm gonna use, it doesn't really matter.
First one.
The first one. Okay, we're gonna do the first one then. Cool. Again, applying the formula from A to B. My formula is f prime of x, so it's x prime multiplied by g of x, e6 x over 6 dx, plus integral of from A to B. Again, you got to carry the A to B after it. F of x untouched multiplied by e6 x 6 derivative dx has to be equal to x multiplied by e6x over 6 between A and B. Okay. In my case, I forgot to say that A and B are 0 and 1, but okay. Cool. So this is the formula. Now, let's actually compute it. I'll switch pages, but you can follow me in the notebook. So, as I said, my initial case was 0 and 1. So A is 0, B is 1. You can replace it with whatever cases, with whatever you have to compute. So I have to compute integral 0 and 1. What is the derivative of x? You can check, I'm doing exactly, I'm computing the previous equation. So that's x derivative is 1 multiplied by e6x over 6 dx plus integral 0 to 1 x multiplied by, what is the derivative of e to the power of 6x over 6? It's just e6x dx, okay? Because that's how I created it to be. And this is just equal to x multiplied by e6x over 6 from 0 to 1. Now, you know, this is the thing I want to compute. This is the thing the problem told me to compute, right? I changed positions, nothing else changed. Like now it's the second one instead of the first. Doesn't matter. This I know. So I have to compute this. Well, what is that? It's integral from 0 to 1 of e or 6x over 6 dx. Again, I'm going to take out the 1 over 6. Okay, and we already computed this thing. So this is just equal to 1 over 6 multiplied with. Remember how we do the definite integrals, right? We write the primitive, and then we take it between 0 and 1. Okay? So this is just equal to 1 over 6 multiplied by e, and I replace 6 multiplied by 1 over 6 minus e 6 multiplied by 0 over 6. Okay? Just computing the definite integral right now. That's all I'm doing. So this is equal to 1 over 6 e to the power of 6 over 6 minus 1, 6. Okay? So this is computed. Now, I had to compute this. So I'm kind of done. This is done, and this I have to compute, but I know how to. And I'll show you right now. Let's do it like this in a column as well. Let's do it. So I said I know this. Let's do it like this. Let's split it in columns. I know this. And what is this? Again, this line thingy, when it says between 0 and 1, what it means is just plug in the values and subtract them. Okay, fancy term for plug in and do a subtraction. So I plug in 1, which is 1 multiplied by e power of 6 multiplied by 1 over 6 minus, and plug in the 0. 0 multiplied by e is 6 to 0 over 6. Okay, that notation, that line between 0 and something, or between a and b, fancy notation, plug in b and a and subtract them. Okay, so what do I get? This becomes 0 because it's multiplied by 0, so I just get e to the 6 over 6. Okay, so where am I now? I want to compute this, and I know this and this. So I'm done. What is my equation? My equation is 1 over 6 e to the 6 over 6 minus 1 minus 6 plus the integral I want to compute is equal to e to the power of 6 over 6. Okay, I just replaced what I did the computation. So my definite integral is just equal to subtract them. Problem done. Any questions on what I did? Obviously, no constant here. I mean, this is a number. E is like 2.7, so 2 point something. So this is gonna be a number. I don't know what number it is, but it's a number. So I'm done. Let's say for convenience, it's no. You can plug it in the calculator and replace it. Okay, it's a number. So I'm done. Any questions on what I did? Yeah.
You don't need to solve the 1 over 6 thing. You can just write it like that.
It's there's nothing to solve. It's just a number. Like e is 2.7. So I mean, yeah. At this point, you just plug this in the calculator because you're allowed a calculator on the exam or whatever. And this is just e is 2.7, right? So it's just plug in there and dot dot dot. I don't know. There's it's just a computation. Can you leave it like this? Probably. Honestly, probably. It's a number, and I didn't have my calculator on me. I don't know. Again, even if you leave it like this and you find the grader that's in an extremely bad mood, just so I don't use other words, they're probably going to take 1 point out of 40. So I wouldn't stress about it. Okay. Any other questions? Again, I only have like what, 5, 10 more minutes. So now no point in starting another exercise. Rather just go through what we did on this exercise and repeat it again. And then we're done, okay? So I gave you this thing that you had no idea how to compute. This thing. And I told you, you need to apply by parts to it, or you remembered, hey, I can apply by parts to it. You split it into your two cases, okay? X and e to the 6x. And then I told you got to compute the integral of one of them. And remember, exponential is a great choice. Whenever you have something multiplied by an exponential, consider applying by parts and taking the integral of the exponential. Because as you probably noticed, our results are kind of nice. Like there was no fancy computation. It was quite simple outside of like numbers, which whatever, but computation was simple. So I noticed that these are my two parts and I choose the second one, exponential, because I got a hint that it's a really good place to start. I compute the antiderivative, the integral of this thing, and I get it be equal to this. Okay. This automatically, this value is going to be one of my two functions that I use in the by parts, either f or g. Which one you choose, I don't care. Nobody cares. You're gonna get the same result. Okay. So I just choose one of them, either g or f, to be that value. Okay. And the other, respectively, is going to be the remaining term, which I did not integrate. So x in this case. Okay. After this, I just replace inside my formula. After I've gotten my f and g, whichever you choose again, I just replace in my formula. Replace in the formula above. Replace the values in. I chose this one, so this is my replacement. Okay. Replaced in. And after you've replaced, you just start doing the computation. What is the computation? I just have x derivative, which is 1, multiplied by whatever this is, dx, plus the integral from 0 to 1 of what I wanted to compute in the first place. And that is the whole idea, that if you apply the by parts the way I taught you, one of these two terms, one of these two integrals is always going to be the integral you want to compute. Okay, that's the whole idea. One of these two is always going to be the thing you want to compute. In my case, the second one. This is what I want to compute. And this is equal to x multiplied by basically f and g multiplied between them. And I have to do between 0 and 1, which are my initial bounds of the function. Okay, now, middle I want to compute, so I try to do the other ones, left and right. Left one, this is why I choose exponential, because it's so nice when I do the math. See, like my x derivative became 1, so I got rid of it. And now I just got to compute a definite integral of an exponential, of an e, which there's a formula for it in the book, and probably you're going to have a cheat sheet for it. So this you can compute, okay? Dot, dot, dot. This is the antiderivative of this. And as you work with definite integrals, you just add them between 0 and 1, which fancy term for replacing the bigger one and subtracting the small one. Okay? Did that, got this result. So I know the first term. I know the first term, I don't know the second term, and I'm gonna compute the third term. The third term, no integral, I just have to do f multiplied by g, in my case, x multiplied by e6x over 6 between 0 and 1. And I just do that. I replace, bigger value, replace bigger value minus smaller value. Okay, do the computation, 0 multiplied by this is 0, and I just get this. Okay, so now what does my equation look like? This thing, which is my first term, plus the thing I wanted to compute in the start, is equal to e to the power of 6 over 6, which is a constant. I think it's like whatever, like 200. Let's say it's that 200. That's a number. Okay. So I know, don't know, no. So I can just take the integral out, move this on the other side, have them as a subtraction, plug in the calculator, get that the result is 25. Done. Cool. Any questions on my parts? If not, no, I guess we ended up here, and we're going to start substitution next week. Bye, Zoom. Catch you later.